Hello and welcome. In this video, we will be looking at the 5 hardest questions from the AQA GCSE Maths paper from June 2017. This is paper 1 and it's the higher paper. So in this series, my students who are mainly aiming for grades 7, 8 and 9 at GCSE have voted for what they believe are the hardest questions in this exam paper. And I will be going through the 5 questions with the most votes. You can download a copy of the paper using the link below as well as the mark scheme. Have a go at the questions and then go through the video. This paper is out of 19 marks, so try to complete these questions in 19 minutes. Remember, this is paper 1, so it's a non-calculator paper. Let's get started. The first question, which is question 18 in the exam paper, is worth 3 marks. Bottles of drink are for sale at 3 shops. The normal price of the bottle is the same at each shop. So let's call the price X. So the price of the bottle is X. So shop A has an offer, buy 1, get 2 bottles more at half price. Shop B, buy 2 bottles and get 3 more bottles at half price. Shop C, just 30% off a bottle. What is the cheapest way to buy exactly 8 bottles? Now you can buy from more than one shop. You must show you're working out. Right, so let's have a look at how much it's going to cost me if I buy from shop A. Now if I buy 1 bottle, I get 2 bottles at half price. So in the end I'm going to end up with 3 bottles or in multiples of 3. And how much would the 3 bottles cost? Well, the first bottle would cost me X. The second bottles and third bottle would cost me half X. So that's going to be another X for the 2 of them. So it's going to cost me 2X. So let's write that here. So the number of bottles is 3 and then the cost is going to be 2X. Shop B, buy 2 bottles, get 3 more bottles at half price. So in total I'm going to end up with 5 bottles. And how much will this cost me? Well, the 2 bottles will cost me 2X. And then 3 bottles at half price. So that's going to be 3 over 2X. So 3 over 2X plus 2X. So 2X is 4 over 2. 4 over 2 and 3 over 2 is 7 over 2X, which is 3.5X. It's going to cost me 3.5X to get 5 bottles. And shop C, I can just buy 1 bottle, so the number of bottles is 1, and I get 30% off a bottle. So if the original price of a bottle is X, 30% of that would be 0.7X. Okay, so we now need to work out the cost of 1 bottle from each of these shops. So shop A, I can buy 3 bottles for 2X. That means that 1 bottle, so the cost of 1 bottle will be 2X divided by 3. So 2/3 X. Shop B, how much does 1 bottle cost at shop B? Well, I can get 5 bottles for 3.5X. So the cost of 1 bottle is going to be 3.5X divided by 5, which is going to be 0.7X. And from shop C, we already know that it costs 0.7X. So these are the cost of 1 bottle. Now, 2/3 X is cheaper than 0.7X. So ideally, we want to get most of our bottles from shop A. Now, the problem with shop A is we have to buy them in multiples of 3. So if I want to get 8 bottles, 3 is not enough. So I either need to buy 6 bottles from shop A or 9 bottles from shop A. So if I was to buy 9 bottles from shop A, that would cost me 3 lots of that, so 6X. Right, now I need 8 bottles, so I've actually got 1 extra bottle, but it's costing me 6X. Now if I buy 6 bottles from shop A, that's going to cost me 2 lots of 2X, which is 4X, but then I need to get 2 more bottles. Now from shop B, I need to buy a minimum of 5, so let's go to shop C. Now shop C, I can buy 1 bottle for 0.7X, so I need a further 2 bottles. So 2 bottles from shop C will cost me 0.7x times 2, which is 1.4x. So in total, this is going to cost me 4x plus 1.4x, which is 5.4x, which is cheaper than 6x. So the cheapest way to buy exactly 8 bottles is from shop A, buy 6, and from shop C, buy 2. The second question we're going to look at is 21 in the paper, and it's worth 4 marks. Part A, the diagram shows rectangles A and B. Rectangle A can be mapped to rectangle B by a single transformation. Javid says the only single transformation is a reflection in the y-axis because the rectangles are on opposite sides of the y-axis. Is he correct? So if that is true, we can reflect it in the y-axis and that will get me from A to B. But the question is there another single transformation that takes you from A to B? Well, the other single transformation is a translation. So is he correct? No. Give a reason. Because I can do a translation, which is moving the shape. And if I start there, this point ends up here. So that's moved 1, 2, 3, 4, 5, 6. 6 units to the right. So another transformation for this could be 6 units to the right. A translation of 6 units to the right. Part B. The diagram shows triangles CDE and PQR. CDE is mapped to PQR. So this is where we're starting, this is where we finished. By combining 2 single transformations. The first is a rotation of 90 degrees anticlockwise about E. So here is E. We're going to rotate this triangle 90 degrees anticlockwise about E. So that means that this point here, which is 3 above, will now end up 3 to the left. So point D would now end up here, and point C would now end up here. And point E would remain where it is. So here is the triangle after the 90 degree rotation anticlockwise about E. Now describe fully the second transformation. So the different transformations we have are translation, reflection, rotation, and enlargement. So if it's a translation, that means we move the shape. So from here to here, we can't simply move the shape because it's a different shape altogether. It's a larger shape. So we know it's not a translation. And again, if it's a reflection, they need to be the same size. So it's not a reflection. And also a rotation would imply it's the same size as well. So it's not a rotation. This one is a different size. So this one will be an enlargement. Now we need to find out where the center of enlargement is and the scale factor. So what we need to do is we need to draw some lines from the original shape to the enlarged shape. So point E has been transformed to point R. So we need to draw a line from E to R. Now point C has been transformed to point P. And point D has been transformed to point Q. As you can see, all 3 of these lines intersect at this one point here. So describe the second transformation. Well, firstly, we're going to say it's an enlargement. And the center of enlargement is that point there. So we need to give the coordinates of it, which are -1, 0. And then finally, the scale factor. Now the shape has been inverted, so it's a negative scale factor. And how many times bigger is it? So we started with this distance here was 2, and it's now 4. So the scale factor is twice as much, but it's been inverted. So instead of just 2, it's -2. So the scale factor is -2. The third question is question 26 in the paper, and it's worth 4 marks. Expand and simplify this expression here. So what I'm going to do is I'm going to keep the x minus 4 on its own, and I'm going to multiply the 2 brackets on the right together, just using FOIL. So that times that is 4x squared. That times that is plus 6xy. That times that is plus 6xy. And that with that is plus 9y squared. If we simplify this, this is 4x squared. 6xy is plus 12xy plus 9y squared. And now what we need to do is we need to multiply the first bracket by the second bracket. So we're going to multiply the x by the 4x, then the x by the 12xy, and then by the 9y squared. So x times 4x squared is 4x cubed. X times 12xy is plus 12x squared y. X times 9y squared is plus 9xy squared. Now we're going to multiply the minus 4 by everything. So minus 4 times 4x squared is minus 16x squared. Minus 4 times 12xy is going to give you minus 48xy. And minus 4 times 9y squared is going to be minus 36y squared. Now, does anything in here simplify? We've got an x cubed, and then an x squared y, an xy squared, x squared, xy. No, nothing simplifies. So this line here is your final answer. The fourth question we're going to look at is question 27 in the paper. So point P, which has the coordinates of minus 1, 4, is on a circle, center O. Work out the equation of the tangent to P, to the circle at P. So if I draw a line from O to P, we know that the angle between the tangent and the radius is always going to be 90 degrees. So what we can do is we can work out the gradient of the line OP, and then because this line here is the tangent, it's going to be perpendicular, so we can work out the gradient of this line. So the gradient of OP, so the coordinates of O are 0, 0. The coordinates of P are minus 1 and 4. So this is the x coordinate and the y coordinate, x coordinate, y coordinate. So that's x1 and y1 because that's the first coordinate, x2 and y2 because that's the second coordinate. Now the formula for gradient is y2 take away y1 divided by x2 take away x1. Or you can use the change in y divided by the change in x. Now y2 is 4, take away y1, which is 0, divided by x2, which is minus 1, take away x1, which is 0. This gives me 4 divided by minus 1, which is minus 4. So if the gradient of the line OP is minus 4, the gradient of the tangent will be the negative reciprocal of OP. So the gradient of the tangent is going to be minus 1 divided by minus 4, which will be 1/4. So we now need to find the equation of this tangent. So we know that the gradient is 1 over 4. We know the x coordinate is minus 1 and the y coordinate is 4. So if we use the equation y equals mx plus c and we substitute these three values in, y is 4, m is 1/4 times minus 1 plus c. So 4 equals minus 1/4 plus c. If we take the minus 1/4 to the other side, we get c is 4 and 1/4, which is the same as 17 over 4. So now we know the value of c. We also know the value of m. So to give our answer in this form, it's just going to be y equals m, which is 1/4, mx, plus c, which is 17 over 4. That will get you the 4 marks. The fifth and final question is question number 28 from the paper, and it's also worth 4 marks. So the volume of a cone is equal to a third pi r squared h, where r is the radius and h is the perpendicular height. A cone has a horizontal base of 5 centimeters and a height of 15, so that's this large cone here. And then the cone contains water to a depth of 9. Work out the volume of the water. Well, the volume of the water is in the shape of a frustum. So the volume of a frustum is what we need to work out. So the volume of the frustum is equal to the volume of the large cone minus the volume of the small cone being this bit on the top here. So we need to find some information about this small cone. So if I just redraw it, we need to know its height and we need to know its radius. So the height, we know the height of the large cone is 15 and the height of the water is 9, therefore the height of this must be 6. Now these two cones, this large one and this small one, must be similar. So if they are similar, then their radius and height must be in the same ratio. So if we do radius divided by height for the small one, this should be equal to the radius divided by height for the large one, which is 5 divided by 15. So we solve this equation, we get r is equal to 5 over 15 times 6. This gives us 2 centimeters. So the radius of the small cone is 2. Now we need to work out the volume of the large cone and the volume of the small cone. So the volume of the large cone is 1/3 times pi times the radius. So the radius is 5, so 5 squared, times the height, which is 15. We simplify this. 15 times 1/3 is 5. 5 times 5 squared is 5 cubed, which is 125 pi. Now the volume of the small cone, same formula, so it's 1/3 times pi times the radius, which is 2 squared, times the height, which is 6. And if we simplify this, 1/3 times 6 is 2. 2 multiplied by 2 squared is 8. 8 pi. Therefore, the volume of the frustum is equal to 125 pi, because that's the volume of the large cone, minus 8 pi, which is the volume of the small cone, which is 117 pi. So the volume of the water is equal to the volume of the frustum, which is 117 pi, for 4 marks. Thank you for watching our video on the 5 hardest questions from the June 2017 Higher Paper 1. If you found this video useful, please let us know by giving us a thumbs up and leave us any feedback in the comments below. Please share this video with anyone who you know may find this useful. Remember, for more content like this, hit the subscribe button. Until next time, goodbye.